Okay, so in 6.1, we will talk about angle measures. The learning targets are I can draw angles of rotation and I can find coterminal angles. Just as a reminder, I want you guys to remember about an angle in standard position. We'll get to that. Go ahead and look at the two triangles, both with the same angle measure of theta. They have different lengths or measures of the sides of the triangle. But although the distances of r prime and y prime, so y prime and r prime, are different from y and r, the ratios will be the same. Well, why is that? It has to do with the angles of theta being the same for both triangles. They're similar triangles, as you would have learned in geometry. Their sides are proportional. This means that regardless of the radius of the circle, the sine and cosine of a given angle will always be the same. So the sine theta equals y over r would equal the sine of theta of y prime over r prime with the same given angle of theta. Same thing for the cosine. The ratio of the cosine for this triangle would be the same as the cosine ratio for this triangle, just as long as theta is the same. It does not matter of the size of the circle or triangle. A couple of things that you should remember. An angle in trigonometry is formed by an initial side, the ray. We put that on the positive x-axis, as I'll show you that in a second, and a terminal side, which is the ray. And I'll show you that as far as going counterclockwise or clockwise. And then the rotation angle. An angle drawn on the coordinate plane that is in standard position is if the vertex is at the origin and the initial ray is along the positive x-axis. This is called the standard position. Just as long as you have your initial side here on the positive x-axis and the vertex of the angle at the origin, and then you have another ray called the terminal side somewhere other than the initial side on the positive x-axis. If you go counterclockwise rotation, that is a positive angle. If you go clockwise rotation, as you can see with the arc angle, that's a negative angle. So positive, I would go counterclockwise. Negative angle, I would go clockwise. Standard position. Also, make sure you are clear that a complete rotation is 360 degrees all the way around the circle. Otherwise, we know it in radians as 2 pi. Obviously, if it's positive, you're going counterclockwise all the way around. If it's negative, you go clockwise all the way around. The measurement angle is the amount of rotation about the vertex needed to move the initial side to the terminal side. So the question is, what is the size of this angle or the measure of this angle from the initial side, remember on the positive x-axis, to the terminal side? What is the measure of that angle? When we talk about angle measure, that is what we're talking about. One way to measure an angle is in degrees. We will actually be looking at more so radians. So a second way is to measure an angle is in terms of the real number distance along the circle. T, this measure is called radian measure because 1 radian is equal to 1 radius wrapped around the circle. So I want you to think about this here. You think about if this is my angle theta. This is my angle theta. When we talk about radian measure, we talk about the radian measure being 1 radian is equal to 1 radius wrapped around the circle. All right, so it's wrapped around the circle. Radians. So measure of an angle in radians is the length of an arc that subtends the angle, meaning that it's a portion of the circumference. If you remember from geometry, circumference is the distance around the circle. So we're talking a portion of that distance around the circle. So what is a radian? A measure of an angle in radians is the length of an arc. So part of the arc that subtends the angle. So part of the circle. It is a measure of rotation in terms of pi. Sometimes you'll see it in decimal form. Remember that pi is 3.14. It describes an angle as a real number as opposed to a degree, which is not necessarily a real number. Degree is an angle around a circle, but any given circle. 1 radian equals the distance of 1 radius wrapped around a unit circle. We already talked about that, where the unit circle has a radius of equal to 1. 1 radian, if we had to change it into degrees, is about 57.3 degrees. As you can see, here's 1 radian. Halfway around the circle is pi. Quarter way around the circle is pi over 2. And if you look right here, you will see that this is 2 radians, which represents one length of the radius and a second length of the radius. Coterminal angles. A simple way of thinking about coterminal angles are angles that basically have the same terminal side. Basically, they start and stop rotation in the same exact place. But think about it. You can go around the circle amount of 360 degrees or 2 pi. As long as you keep on doing that forever and ever, you'd have coterminal angles. So by adding or subtracting 360 or 2 pi, we would have coterminal angles. So you can think about 40 degrees and then going around. This is a 40-degree angle, but we go around this way. Negative 320 degrees is also the same terminal side. Those are coterminal angles because they end in the same spot. Go this way, again, going this way is 40 degrees. That's the counterclockwise direction. Go clockwise, negative 320 degrees, and you stop at the same terminal side. That is a coterminal angle. So by adding or subtracting 360 or 2 pi, we have coterminal angles. So it says find one positive and one negative angle that are coterminal to the given angle. How do we do this? Just as we said, if it's degrees, add or subtract 360 degrees. If it's in radians, add or subtract 2 pi. How do we know something's in radians or degrees? Make sure if there's a degree mark, it's in degrees. If there's no degree mark, like this 4 here in this example, it's obviously radians. Let's take a look at the first one. 590 degrees, if I subtract 360, 230 degrees is coterminal with 590 degrees. I can take that 230 degrees, subtract 360 again, and I get negative 130 degrees. Again, that's a 1 positive and 1 negative coterminal angle to 590 degrees. Don't forget, there's an infinite amount of coterminal angles because I could, again, subtract 360 again, or I could add 360 to 590, and I would get another coterminal angle. Let's take a look at 15 pi over 2. If I want to think about 15 pi over 2, I think about my common denominator. So I could subtract 12 pi over 2 to get to an angle between 0 and 2 pi to be 3 pi over 2. But if you think about 4 pi over 2 as being 4 pi over 2 being 2 pi, I could take 15 pi over 2 and I could subtract. Let me just show you. I could subtract 4 pi over 2. And that would equal 11 pi over 2. That's the best you guys are going to get. Sorry. 11 pi over 2 is also coterminal to 15 pi over 2. All right, just keep that in mind. But I got 3 pi over 2 because by subtracting 4 pi over 2 multiple times, you would get to 3 pi over 2. Any of those answers will be fine. All right. Let's find the negative. Now, by subtracting 4 pi over 2 from 3 pi over 2, I get negative pi over 2. That's a negative coterminal angle to 15 pi over 2. Again, I could keep on subtracting 4 pi over 2, and I get negative 5 pi over 2 if I wanted, and that's also coterminal. For 4, remember, think about 2 pi pi as 3.14, so 2 pi is 6.28. If I add 6.28, I get 10.28 as a positive coterminal. If I subtract 6.28, I get negative 2.28. Again, that's a positive and a negative coterminal angle to 4, to the angle 4 radians. Okay, there's 2 different methods to figure out if angles are coterminal. So the question is 11 pi over 4 and 3 pi over 4 coterminal? Remember the definition of coterminal. There's 2 different methods. First method, we can continue to add 2 pi to the smaller angle until you get to the bigger angle. As long as they overlap, then they're coterminal. Or as long as they get the same angle, they're coterminal. So I'll take the smaller angle, 11 pi over 4, and I'll add 2 pi until I get to 3 pi over 4. Make sure you have a common denominator. So I use 8 pi over 4. Remember, that's still 2 pi. I get 19 pi over 4. Add 8 pi over 4 again. I would get 27 pi over 4. And then add 8 pi over 4 again. And of course, I get 3 pi over 4, which is exactly what I wanted to get. So therefore, 11 pi over 4 and 35 pi over 4 are coterminal angles. Second method, I could just subtract the angles and then see if the result is a multiple of 2 pi. I take 35 pi over 4, that's the bigger angle, and subtract 11 pi over 4, and I get 24 pi over 4. Well, guess what? 24 pi over 4 is 8 pi over 4. 8 pi over 4, if you divide that, is 2 pi. Or if you take 8 pi over 4, multiply it by 3, I get back to 24 pi over 4. So yes, it is a multiple of 2 pi. So basically, if you subtract and then you can simplify all the way down to 2 pi, then yes, they are coterminal angles. Again, remember your definition of coterminal. Now, here's the example where it says find an angle between 0 and 360 or 0 and 2 pi that is coterminal with the given angle. Just like we did before, I subtracted. I'm going to go back right here where I subtracted until I got an angle that was 3 pi over 2. Remember, I used this method where I said, okay, 11 pi over 2 is also coterminal, but it's not an angle between 0 and 2 pi. 3 pi over 2 is. So it's just jumping your head a little bit. So now if the question asks you to give an answer between 0 and 360 or 0 and 2 pi that is coterminal, you'll have to keep on subtracting. So let's take 1,560 degrees, and let's get that to be a coterminal angle between 0 and 360. What will I do? Keep on subtracting 360 until I get to a number between 0 and 360. You can see I subtracted once, twice, 3 times, a fourth time, and finally I'm at 120 degrees. Why is 480 no good? Why is 840 no good? Why is 1200 no good? Because they're not between 0 and 360. But if I keep on subtracting 360, I get to 120 degrees. That is between 0 and 360, a coterminal angle to 1,560. Don't forget to label your degrees. For radians, 77 pi over 6. Remember, 2 pi, I want a common denominator. So 12 pi over 6 is the common denominator to 77 pi over 6. I'll do the same exact thing. Keep on subtracting 12 pi over 6 until I get to a number between 0 and 2 pi. There you go. I had to subtract it a number of times until I got to 5 pi over 6. A faster way of doing that would be take 12 pi over 6 and take that 12 and double it. Basically, in this time, 1, 2, 3, 4, 5, 6 times. 1, 2, 3, 4, 5, 6 times is where I'm getting that. 6 times 12 is 72. Yes, 72 pi over 6. If I took 77 pi over 6 and subtracted 72 pi over 6, I would get 5 pi over 6. Not necessarily faster, but if you can see it that way, do it that way. But it has to be a number between 0 and 2 pi. If you're not clear if a number is between 0 and 2 pi, divide. 6 goes into 17 twice and then some. All right, so if it goes in there twice, that's more than 2 pi already. That is 2 pi, but then if there's some more, that's more than 2 pi. Just make sure that it is between 0 and 2 pi when you simplify.